Welcome to PLC in Action YouTube channel. Today topic is Absolute versus Symbolic DB. Okay, what is mean by this Absolute versus Symbolic DB? We'll see detailedly with some examples. Okay, so what is these two? Okay, these two it's a important addresses. Okay, not addresses. What is it? The two type of DBs. We can define the DB which way you want to use. Okay, first one it's a absolute DB. Second one is a symbolic DB. Okay, before it was normally the default DB will be absolute DB. Okay, it I can show you. Okay, but now recent updates, I don't know from the which tier version, the absolute become a non-default, the symbolic will be a default one. Okay, I will explain you one by one so that you can easily understand. Okay, first we will add one DB and I will show you. Okay, first I will add is a symbolic DB, name as a symbolic DB. Okay, I just created the stuff. It is symbolic DB. Okay, I'll just make some motor. Okay, motor on, some kind of on button. Okay, next motor off button, motor output. Okay, now this three variable we created. Okay, there is a on off and one output. Okay, this is symbolic DB. Okay, next we'll create the same stuff with the absolute DB. Okay, I've just created another one, absolute DB. Okay, now here you have to change something in the properties. Okay, right click, properties. Here this is important, optimized block access. It means optimized DB called symbolic DB. Okay, if you remove this thing, it will become a absolute one. Okay, you just click OK. Okay, you see now we will use the same these three. I just copy and paste. Okay, and I will download. Okay, now I will open both side by side. You can see the difference. Okay, if you see what to say that generally we don't feel the difference, but here the one main difference is there. You see the offset. It means it will allocate the memory as per your data type. Okay, example, if you create the booleans, it will be allocate the memory likewise. Here it will not allocate the memory. It means this DB will not memory based. Okay, this DB will be your memory based. Example, I will create a few more stuff here. Okay, example, I will create a one integer. Okay, I will create the same integer here also. You can understand. Okay, if you see after the 0.2, it's take a 2.0. It means once you allocate the one bit here, the Siemens have a integer. Okay, so it will take the 0.0 to 1.7. It will take entire byte. If you create the another integer, it starts from 2. Okay, in this case, example, you have some, okay, I can say some boolean 0.3. Okay, it means I can say boolean 1. Okay, I've created some booleans. You see, these many booleans are default. It is created. It means even though if you are not created, it will allocate the memory. Now this is our existing integer. We created the same integer, right? Okay. You see both. Now it is the same thing here. Okay. These booleans are default, it will allocate, but here there is a no need of memory. Okay, it will work based on the symbolic means the name only it will check, it will not check the your address. Okay, this is the two type of address based it means memory based one is name based one. Okay, this is the key difference. The DB itself, every if you create the variables data type, whatever the data base will on the data type, it will allocate the memory in the DB. But here the symbolic one, it will not allocate the any memory. It will be a considered as a name as a key thing. Okay, let's create a small logic so that we can you can understand few more. Okay, now we have a this is absolute DB. Okay, this is a Siemens name optimized. Okay, that is as a S7-1500 we called it symbolic. Okay, here they called as optimized, so we can call the same optimized. Okay, so we just made over some logic. Okay. Okay, just on off. Okay, for understanding the small logic, so that you can understand how we can use the same absolute and the stuff. Okay. Okay, you just see now the same logic. Okay, we are using same. It means similar logic, but the different two type of the DB. One is absolute DB. We are using it is address based. You see DBX T 0.0, DBX 0.1, DBX 0.2. It is use the address. Here it is use the names. Okay, this is the absolute address based. This is symbolic address based. Okay, this is the key difference. Okay, and if you want to next, we'll just move some array. Sorry, some integers. Okay, absolute DB will show some move. Okay, we just move some. Okay, we just move one into absolute. Okay, you can see db7 dbw. W means word, so word 2 it is taking. Okay, next we'll use optimized. You see, it's the same move block, but we are using two different DBs. I can just show you in the online. Okay, just like this is absolute. Okay, if you off, same logic. Okay, I've just made on and off. Okay, here it is also the moving the same thing. So this is the key difference of using two different DBs. Okay, maybe what is the what do you say that which which one we can use it for which one? That's a very important question. If your program, okay, you are using for kind of pointers. Okay, you want to move for a pointers, you want to use some kind of that kind of calculation, then the absolute address is the best one. Okay, because it is the ability to point the address. Example, you have 100. Okay, you want to point only in between 40 to 60. Other first 20 bytes you want to move. That kind of logic you can use the absolute address. That is the easy one. And if you want to use the pointer, the symbolic and optimize is not possible to do the point move. Okay, maybe I can show you something, the point move, so you can easily understand. Okay, so okay, test extract into one. Okay, so we have okay, now we just made the same structure in the absolute also. Okay, you see this also one structure we created. This is also same. Okay, I can visit here. To show, okay, for this we needed two. Okay, so I will add one more. Let's see, test one, test two, because I want to move the 1 and 2, so I just to use it. Okay, okay, now I will move. Okay, just use the simple move. Okay, this is from the absolute one. You see, P hash DB7 DBX 4.0. Okay, it is moving, but it is a pointer. This is called pointer based one. Okay, PS DB7 DBX 24. Okay, this is fourth one. This is 24. Okay, in this case, similar kind of structure only you can move. Okay, example, if you have something added here. Okay, example. Okay, if I added some, you see the right side it is changed. Okay, maybe I can compile so that you can easily, you see the left side is okay, right side is not equal, so that's why it is not showing. If I delete this, because if you have a memory based one, it means if example you have 10 bytes, the right side also it should be 10 bytes, then it will move one 10 bytes to another 10 bytes. Okay, that's a concept here. Okay, same, next we'll use the optimized. You see, this is also another kind of, okay, it will just move the thing. It is the same stuff. We are using two different things. Okay, but the Siemens recommendation for the using of address, right? That is optimized too, because they want to use the optimized one because it is having the lot of advantage for the thing. Example, if you're using memory, it will occupy the most stuff, but the symbolic one will not occupy the most of. Example, I can show one more thing, okay, so that you can understand. Example, already I shown, right? In this case, okay, this is absolute, right? If I insert something in between, this will entire structure will be changed. Example means it is 0. Example 0.7, right? If you insert something means the boolean 6 before 1.0, after something insert, it will change the number. So the entire memory allocation is changing. Okay, it is disturb the structure. But if you insert something here, okay, I will insert. Then we can easily add test pool. You see now this is changed to 1.1. Before it was 1.0. Okay, if example I will add the same structure here. Okay, nothing will change here. It means you can add anything. Okay, it will check only the name of the data type. Okay, so there is no problem for using this one. Okay, based on the application you can use the both, but the Siemens recommendation using the optimized one will be beneficial for the thing. If you're using the data kind of moving, it will be easy for you. Okay, if you want to traditional some pointer move, some kind of get put communication thing, that is the absolute address is very useful. Okay, based on your application you can choose whatever you want. I think this topic will give some kind of information about the data block, what kind of data block, how we can use the data block. So I hope it will be useful for someone. Thank you guys, bye, see you in next video.